zeroing in on the processes that started life on Earth. Today, in Mikey's lab. Welcome back to Mikey's lab. If this is your first time joining us, go ahead and click that subscribe button down below. That will ensure that you get the latest updates from my lab on science, DIY, engineering, making, and technology. RNA, or ribonucleic acid, has long been believed to have been a predecessor to DNA. One of the key factors that makes this belief possible is that RNA is not just a repo for genetic information the way DNA is. It also contains the ability to speed up the biochemical processes that are required for simple forms of life. However, one of the biggest challenges facing the biochemists who are chasing this RNA origin story was finding a very simple process with the base chemicals that were known to be present on early Earth that could form the 4 nucleotides that make up an RNA sequence. Well, now chemists seem to have gotten a lot closer to unlocking the last step. Now chemists have found a simple set of reactions that, using the raw materials that were believed to be present on early Earth, can generate close cousins of the 4 nucleotides required for RNA. It is not a perfect match, but it is close enough to believe that these scientists are well on their way to discovering the final steps towards what produced RNA on our planet. The nucleotides in RNA, I'm going to read these names simply because, The nucleotides in RNA are commonly known as adenine, guanine, cytosine, and uracil. These are the 4 nucleotides that make up an RNA sequence. In this list, C and U are very close structurally, and as such are known collectively as pyrimidines, whereas A and G are again very similar structurally and are known as purines. In 2009, researchers led, don't want to mess up this guy's name, by Matthew Poner and John Sutherland in Cambridge, London, came up with the first plausible method of generating the pyrimidines. However, it seemed that very different conditions would be required to cause the evolution of purines. This raised the obvious question that if 2 completely different sets of circumstances and 2 completely different sets of processes are required to generate the 4 nucleotides required for RNA, how could all 4 of those nucleotides be present in the same place at the same time to give rise to RNA to start off the evolution process that in the end created us? Poner, who moved to University College in London in 2012, has found a way to extend his previous research to create close cousins of the 2 missing nucleotides. The process starts with a very simple sugar that is believed to have been present on early Earth, aldehyde. Through simple reactions, the aldehyde can be transformed into compounds that resemble the A and G nucleotides that were missing from the previous experiment. Now, as I said, these aren't perfect. One of the big stumbling blocks that the researchers have come across is that, unlike the actual RNA nucleotides, the ones that are being produced through this reaction have a carbon atom that is bonded to oxygen. In nature, that is bound to hydrogen. Now, there's no direct, easy way to exchange oxygen for hydrogen, so that is a big step that they have to overcome at this point. That is a big piece of the puzzle that is still missing, as we are not aware of whether or not these nucleotides can come together to form an RNA analog that has the same properties and has the same abilities that the RNA that we've come to know already does have. But the truth is simple. If they manage to find that last step, and they manage to exchange that oxygen for a hydrogen atom, we will have unlocked a major piece in where life came from in this universe. Well, specifically Earth. That to me is astounding. As somebody who for a long time has kind of more bought into the panspermia approach to life being seeded on Earth, that being the theory that life started elsewhere off of the planet and was transported here by an asteroid or a comet. Obviously talking very simple life, amino acid level stuff. If the RNA process that these researchers are after is proven to be true, then panspermia might not have actually happened. So here's what I want from you. I want you to go down into the comments below. I want you to tell me what you think of both the panspermia theory and this RNA theory. Don't forget to like this video. If you don't like this video, tell me why in the comments below. Subscribe to the channel for all your latest making, DIY, engineering, and science news. Thank you for joining me in the lab, and I hope you learned something today.